Hi sir, this is Emily. So I'm going to do this observation video now. So first I'm going to name a alkane. And for the first step, I have to find out the main chain. So which has the most carbon. So I have to count the carbon. So first I'll count this way. 1, 2, 3, 4, 5. He has 5 carbons for this chain. And for the other way, it's like 1, 2, 3, 4, or 1, 2, 3, 4, which is less than 5 carbons. So I just choose this one to be my main chain, and it will be pentane, because it has 5 carbons, and they're all single bonds. And I have to find out my side chains. So here are 2 side chains, as we can see. Those 2 are both like methyl group here. And we have to make sure the methyl groups has the lower naming number as possible. So if we name from right to left, it will be on the 3rd carbon. And if we name from left to right, it will also be on the 3rd carbon. So it doesn't matter which way we start and end. So I will just choose from 1, and here's 5. So it's on 3rd carbon, has 2 methyl group, and the main chain has 5 carbons, and they're all single bonds. So those information can let me know the name of this molecule. So it will be 3, 3, because there are 2 methyl groups on the 3rd carbon. So a dash, and dimethyl, because it has 2 methyl groups. Pentane, because the main chain has 5 carbons, and they're all single bonds. Okay, so the full name of it will be 3,3-dimethylpentane. Okay, so for the next one, I will name a alkene. So alkene means that it will has double bonds appeared. So we can see here's our double bond. And for this one, we have to ensure that the ending of this name has the lowest number, which will start from here, because we have to let the double bonds has the lower naming number, because it will be the ending of this whole name. So we'll start from here as our carbon 1, and we have to find out the main chain. So as we can see, it will be a cyclic shape. So it will have 1, 2, 3, 4, 5, 6 carbons for its main chain. So it will be a cyclohexene, right? But we have to ensure the double bonds has the lowest name. So we start from this side, because the carbon will be the double bonds will be on the 1st carbon. But if we start from this side, well, what will happen? We can see it's carbon 1, 2, 3, 4, 5, 6. So the double bonds will be on the 6th carbon. So it is not as good as the 1st carbon. So I will just choose to name it from 1, 2, 3, 4, 5, 6 for this way. Okay, so now we all know about the main chains and the ending number. So we have to find out the side chain. So we can easily see that here's a methyl group. So it's on the 4th carbon, right? So we just write as 4-methyl cyclohex 1-ene. Cyclo for the cyclic shape, hexene, hex for the 6 carbons for its main chain, and 1 is where we have the double bonds here on the 1st carbon. So ene is the double bonds. So that's the name for our alkene. And the next is our alkyne. So alkyne means there will be triple bonds appeared. So we can see here is our triple bond. So we also have to determine the main chain first of all. So we can count the carbons. So it's 1, 2, 3, 4, 5. So it's 5 carbons. and 1, 2, 3, 4, 5. For this way, it also has 5 carbons. So either way is good. So it's not really important here. So I'll just choose this way. This for our main chain. Okay. So we also have to ensure that our ending of the name will have the lowest naming number, so which is I. I is where the triple bonds appear, so we have to ensure our triple bond has the lowest naming number. So if we choose this way, like 1, 2, 3, 4, 5, our triple bonds will be on the second carbon, which is pretty good. But from the other way, it will be 1, 2, 3. It will be on the third carbon, which is higher than this way. So it's not good. We just choose 1, 2, 3, 4, 5 instead. Okay, so now we figure out the main chain and the triple bonds. So we have to find out the side chain. So it's here, this one. And we can clearly see that it will be a methyl group because here only have 1 carbon. So it's on the 4th carbon, so it will be 4-methyl pentyne. So the pent will be the 5 carbons for the main chain. 2 will be the triple bonds on the second carbon, and yne will be the triple bonds. So that's how we name this alkyne. Okay, so the last one will be our haloalkene. So as we can see, it's alkene, which means that there are no double bonds or triple bonds. They're just connected by the single bond. So we have to find out the main chain first of all. So it's also a cyclic shape, as we can see, and it will be 6 carbons for this cyclic shape. So its main chain will be cyclohexane because it's a single bond. So it also has a side chain attached. So we have to ensure the side chain has the lower naming number, right? And for the single bond, we don't really need to consider about the ending number. It's kind of different from the double bonds or the triple bonds. So we just need this chlorine to attach the first carbon. So we start from here. So it's 1, 2, 3, 4, 5, 6. We name like this because any carbons on the cyclic shape can be the first carbon. So we can write the 1 dash here, but we can also just ignore it. So we'll write as the chlorocyclohexane. Chloro for the side chain chlorine attached. Cyclo means that we have the cyclic shape for the main chain, and hexane means we have 6 carbons for the main chains and connected by the single bonds. So that's how we name those molecules. And that's it. Thank you for listening. Hope you can enjoy it.